Alrighty, so today we're going to talk about one of the S4S issues that I looked into, which is solar voltaic. So first we're going to discuss the problem that we're solving, the description of the solution, then we're going to go into global change impact, then we're going to talk about some of the benefits and the criticisms, and then we're going to talk about the implementation into society. So what's the problem that this entire project was solving? Well, the problem was, how do we as individuals, communities, and our societies address the causes or effects of global change? Well, we live in the world today where sadly, due to multiple years of CO2 emissions and other greenhouse gases, we have created global warming. The way that our families see it today and how we see the world might not be that way if we continue down this road. Going to coffee with your friend could end up with you almost coughing up a lung. So what's a description of a solution that I researched? Well, I did solar voltaic. What this does is this is the cell that's in solar panels. What does it do? On the basics, it converts sunlight into energy. It's constructed of a PV cell and a semiconductor material. Its length varies, so it depends on what type it you purchase. And one PVC cell creates 1 to 2 watts of power. So here's a little diagram that explains how the actual process works. So energy is absorbed through the glass into the semiconductor layer. And what that semiconductor layer is, it pulls apart the protons and the neutrons and then the electrons. So the electrons end up going through and start flowing. And we know from science that once the electrons start flowing, that's when you've started to create electricity, which is what we use. Now, electricity that's created is DC. It's not the AC that we use in all of our DC has to be converted into AC because majority of our appliances use AC. So the difference is that when you look at a DC, the graph looks like little boxes. AC, it looks like a sine wave. So the surface area and the number of PV cells, the more that you have, the more watts that you can produce, which makes sense. Now, the difference between stationary and moving panels is that stationary stays still, so you only get a certain amount of sunlight during the day. The max, of course, is when the sun is over where that stationary panel is. Now, if you have a moving panel, you can maximize the amount of sun that the PV cells absorb because it constantly moves with the sun, so you're getting the maximum amount of surface area at all angles. So what's the global change impact? Well, it replaces non-renewable energy. It's also a renewable energy source. There's no greenhouse gas emissions and no air pollution when you use solar panels. So what are some of the benefits and the criticisms that come up? Well, some of the nice things, the benefits, are that solar energy is proven technology. It's slowly becoming more and more. There's more and more research being done on it. More and more people are interested into looking into it and perfecting it. It works in many different climates. It's affordable. It benefits your entire electricity grid. It's got a long lifespan. It increases your home value, and it's a non-partisan energy source. Now, what are some of the criticisms? Well, solar energy doesn't work at night. You have to store what you get from the day to use at night. The panels can be unattractive. It must be installed with help. Also, some roof structures can't support solar panels. It does hurt the environment through the process that they're created, and if one thing leaks from the solar panels, it can have a harmful impact on the environment. And some panels are more high quality than others depending on the company you go with. So now let's talk about implementing it into society. Solar is used today on both commercial and residential scales. The technology shockingly improves 0.5% each year. In 2020, solar finally matched its competitors of water and wind as an affordable, renewable resource. So what's the difference in the efficiencies? Well, solar power is not as efficient as fossil fuels, falling about 20% behind. Solar power is long-term available because it's a renewable resource, and it's cost efficient in the end. The bad side of fossil fuels is that it's one of the largest CO2 emissions, but it does have one of the most well-developed technologies since we've been using it for centuries. Now, here are some of the costs. The biggest thing when you go solar is that you get a federal solar tax reduction of 26%. Now, in the end, you're paying cost per watt in Maryland, which is $2.97. Now, positives, of course, on the environmental impacts we talked about, reduces air pollution and CO2 emissions. And the negatives, of course, we said some of the materials in PV cells are dangerous, and commercial use needs to clear large land spaces so that they can have multiple solar panels. Now, looking at the cost for fossil fuels, the cost per BTU in Maryland is $2.83, which is a little bit less than the cost per watt. Now, the positives, it's more reliable, it's cheaper depending where you are. Negatives, of course, it's the lead cause of CO2 emissions, and you have to build large power plants in order to run some of them. Also, humans have higher risk of being hurt in collecting oil. So here's a slide of references if you'd like to review some of the materials that I looked at or get a better insight. But thank you so much for looking at my PowerPoint.